So we've talked about energy and how there are different types of mechanical energy, but we haven't really gotten specific into how do you determine how much energy an object has. So that's what we're going to look at here is figure out how to measure energy, how to calculate energy, so that we can really track the amount of energy that an object has during different phases of its motion. So just a quick recall that there are three types of mechanical energy that are related to motion. Kinetic energy has to do with the motion of an object. So as long as an object is moving, as long as it has a value of speed, then it's going to have kinetic energy. We also talked about gravitational potential energy, and an object has this type if it's above its lowest position, so if it's above the ground. And then we also talked about elastic potential energy, having to do with things that are stretched or compressed. In terms of our calculations, we're going to focus just on the first two. Ideas of elastic potential energy are a little trickier, and it's better for a later course in physics. So let's talk first about kinetic energy. We will use the kind of extended symbol Ke to represent kinetic energy in our formulas. And again, this has to do with motion. All types of energy that we're going to be talking about are going to be measured in joules, and that's abbreviated with a capital J. So the pronunciation there is, it's just like sort of the fancy gems like diamonds and sapphires and rubies and so forth, but it's spelled a little bit differently because it's named after somebody. But joules are our standard unit for energy. To give you a sense of how big kinetic energy is, if there's a child that's running at a decent rate, 5 meters per second, she'll have 500 joules of kinetic energy. If instead there's a man who has twice the mass running at that same speed, he'll have twice the kinetic energy. So there's a simple relationship between mass and kinetic energy, that mass is directly related to kinetic energy. If a different 80 kilogram man is running at 10 meters per second, so the speed is doubled, this has a huge effect on the amount of energy. It actually quadruples the amount of energy. So that is kind of reflected in the formula we use for kinetic energy. This is it right here, 1/2 m times v squared. Just the v is squared. If you take notes, you want to definitely make sure you have this formula written down. It'll be important as we go through our calculations. So let's make sure we all understand the different parts of this formula. First, notice that there is a speed in it. So that's the connection between kinetic energy and motion. Things that have speeds have kinetic energy. M, of course, is going to stand for mass. And just a reminder that we measure mass in kilograms, kg. V is going to stand for speed or velocity, and that's going to be measured in meters per second. And then Ke is going to stand for kinetic energy. And again, that's going to be measured in joules. So let's take a look at an example of how we would use this in a problem. Oh, one more thing. Sometimes people like decimals instead of fractions. So if you would like to write this formula down for your own purposes as 0.5 times m times v squared, feel free to do so. All right, so let's take a look here. We have a car with a certain mass. It's moving, so it's going to have kinetic energy. We're going to calculate how many joules of kinetic energy it has. So let's just kind of list off things we know. The mass, m, is 500 kilograms. The speed is given to us as 20 meters per second. It's not labeled speed, but we'll know by looking at the units, meters per second, that it is a speed, that we should label it with v in our formulas. And then what we're looking for is the kinetic energy. So we should always start by writing down the formula that we're thinking as we solve this question. Plug in the things we know. Again, you may want to change that 1/2 to a 0.5 so that it's easier to type into a calculator and so forth. Now, in terms of doing the algebra here, you want to make sure you do the squared part first. And again, it's just the V that's being squared. And then you might want to do the other parts of the calculation and kind of group that into a number. And so 0.5 times 500 is 250, and 20 squared is 400. But the formula is all multiplication in between all the parts. So we would multiply 250 times 400, and that actually comes out to be 100,000 joules. Now that is a much bigger number than the previous examples, but this is a much larger object, more kilograms, and it's going a lot faster. And so that all plays into how big the kinetic energy is. The other type of energy that we need to be able to calculate is the gravitational potential energy, and we'll use GPE to represent that. Sometimes you just see PE for potential energy, but it is best to make sure we know it's not the elastic type, it's the gravitational potential energy. Remember, this has to do with an object's vertical position or height. And so my picture has a number of boxes that are at different heights above the ground that we're going to look at. Just like all types of energy, gravitational potential energy is measured in joules. Okay, so everything is going to boil down to that unit. Let's start with this green box. It is on the ground, and that means it's at its lowest point, and so it has no gravitational potential energy. It has to be above that point in order to have energy. Let's compare that with this blue box. The blue box is also a 6 kilogram box, but it's up above the ground, 1 meter above the ground. It ends up having 60 joules of gravitational potential energy. And if we look at the red box, which is also 6 kilograms, but it's 2 meters up, so it's at a double the height, it will have double the potential energy. So the GPE is affected by the height of the object. Now if we look again at this blue box and we compare it to this orange striped one, the orange striped one has twice the mass. It has a mass of 12 kilograms, but it's at the same height as the blue box. That doubling of the mass also doubles the energy. So height and mass are two things that are going to affect the gravitational potential energy. So this is our formula. You can see how it's got mass in there, and H is going to stand for height. It also has little g, okay, and so we're going to have to remember that. So the gravitational potential energy does depend on how strong gravity is. So if we were to take our boxes to Mars or something, we would have to do something a little bit different, but we're going to have our problems taking place on Earth. So we will use M for mass in kilograms, but for that value of little g, think back to earlier things we've studied, how the gravitational strength on Earth is 10 newtons per kilogram. And so whenever you do a problem with potential energy, you're going to have to remember to put in 10 for that little g. Always, always, always. And then the H will represent the height, and that should be measured in meters. It's how high it is above the ground, so it's a vertical measurement. And then altogether, you multiply these three values and you get the gravitational potential energy. So again, let's take a look at an example. Here there is a cat sitting on top of a shelf 3 meters above the ground. And so we should be able to determine how much energy the cat has because of that height. We know her mass is 4 kilograms and the height is 3 meters, just organizing the information. And of course, we're being asked to find the gravitational potential energy. But one number we need to remember that's not actually in this problem, but we're going to need it, is the fact that little g is equal to 10. So we're going to multiply the mass times g times h. So 4 times 10 times 3. And grab a calculator if you need to, but that comes out to be 120 joules. Now, these two examples were both finding the amount of energy. You might know the amount of energy and be asked to find one of the other variables. So let's look at that type of example. Here we have a dog who's sitting on that same 3-meter tall shelf, but the dog's energy is 240 joules. And so we're going to determine what his mass is. Let's make a list of things we know. We're given the potential energy. We're given the height. We're trying to find the mass. That's everything that we see in the problem. And then there's this sort of hidden information that we have to remember is out there, and that is that the value of little g is 10. So as we start with this problem, you could rearrange it right away to solve for m, if that's what you like to do, or you could just plug the numbers into the equation and then do some algebra. So I put in the 240 on the left-hand side, left the m, my unknown, as the variable, and then entered the 10 and the 3. I would first do a little bit of algebra on the right-hand side, and I would multiply the 3 times the 10. And I like to write that in front of my variable. You could also have written it m times 30. That would be fine too. Either way, you have to recognize that to break the m away from the numbers, you're going to have to divide by 30. Whatever is being done to m, you need to do the opposite. So we would divide both sides of the equation by 30, and that would leave us with 8. And since that's a mass that we're finding, we would label that 8 kilograms. That's the mass of the dog.